Hi everyone. So in today's lecture, we're going to be looking at the first application of integrals that we're going to be doing, and that is finding the area between curves. So we've already looked at finding the area beneath one curve. So if I just draw in the axes and some function, then if this intercept is A and this intercept is B, then between A and B, there's some area. This area highlighted in blue. Okay, if we wanted to know what that area was, we would say that the area is equal to the integral from A to B, f of x dx, okay, where this function is f. Okay, so that's the area between the function and the x-axis. What we're going to do now is find the area bounded by two curves. Yeah, so not just one. So let's say we've got our x and y axes again. And then we've got this red function like that, and we've got this blue function like that. And we want to find this area that is bounded between them. So these two functions make two intercepts, here and here. Okay, let's call the first one A and the second one B. Between A and B, we see that the red function at the top and the blue function at the bottom enclose this green area or the green region. What we want to do is find the area of this green region. Okay, so how do we do that? Well, let's go back to the definition for the definite integral. Remember, we had lots of vertical rectangles, and we used those to approximate the area. Then we took the limit, and that gave us the exact area. We're going to do a similar thing in this case. So let's just remove the shading here. Okay, so if I just draw in a rectangle here, okay, this is just one of the rectangles that we're going to be using. We know that the width of this rectangle is dx. Yeah, that's the little width. And then what is the height going to be? Well, if the red curve is given by f and the blue curve is given by g, then this height is going to be the upper function f of x minus the lower function g. So this height h is given by f of x minus g of x. Okay, so we take the upper y value minus the lower y value, and that gives us the height. So if we know the height and we know the width, we can write the area. So the bounded area is equal to the integral from A to B. Now we need the height, so that's f of x minus g of x. So that's the height of the rectangle, and the width of the rectangle is dx. Okay, and this gives us the equation we can use. If we are given two functions, where f is the upper function, so this is the upper function, and g is the lower function, then we can use this formula to find the area that is bounded between them. And of course, A and B, those are the intercepts. So let's just make a little note here. A and B are the two intercepts. Yeah, so if you know the intercepts and you know which one is the upper function and which one is the lower function, then you can use this formula to find the bounded area. Okay, so that works fine. But what happens if you don't know which is the upper function and which is the lower function? Sorry. So in some cases, you might not know which is the upper or which is the lower. So if I just give you the two functions, without a diagram, then you can't, visually see which one is upper and which one is lower. So we're going to have to somehow account for that. And the way that we do that is by using the absolute value of f of x minus g of x. So let's see why that works. So if I take the absolute value of f of x minus g of x, then this is equal to, and then we have two parts to it. It's going to be f of x minus g of x if f of x minus g of x is positive. Okay, but f of x minus g of x being positive is exactly the same thing as saying f of x is above g of x. Okay, so in this case, f above g. And that works because f came first and then we had g. And in the next case, if f of x minus g of x is negative, then we put a minus sign. So it's going to be minus f of x minus g of x if f of x minus g of x is less than or equal to 0. But this is the same thing as saying g of x is above f of x. So in this case, g is above f. And in this first part here, we can distribute that minus sign, and we can rearrange this to g of x minus f of x. So now this shows that g is above f. Okay, so by putting the absolute value, we handle both situations. So absolute value of f of x minus g of x handles both situations, one where f is above g and also where g is above f. So f of x minus g of x absolute value handles both situations. Okay, and what are they? Number one, where f of x is above g of x. And number two, where g of x is above f of x. Okay. So in practice, we use the absolute value of f of x minus g of x instead of trying to work out which one is above which. Now, a nice example to illustrate this is if we have the following two functions. So we've got our xy plane. Let's say f looks like this and g looks like this. Okay, so it looks like that. Okay, and we want to know what is the area between them. So we need to look at this intercept and this intercept. Yeah, so this is the region bounded between them. Notice that in this first part, from here to here, that the red is above blue. So let's just label that. Let's say red is f, g is blue. So in this first part, f is above g. And then in the second part, g will then be above f. Okay, so in the single integral from a to b, so from a to b, g and f switch place. So the only way to take care of that is to use the absolute value of f of x minus g of x. So then that will split this up into two cases. The first case on the left, where f is above g, and the second case would be on the right, where g is above f. Okay, and then by using the absolute value and splitting the integral up accordingly, we can handle those two parts. Okay, so if you forget the absolute value, then if this gets switched around, we're going to get a negative area. Okay, we don't want that. So we need the absolute value there. Okay, so that's all the motivation for this formula and what we should do in the different cases. So let's look at an example. Okay, so first example. Let's say we're given two functions. So we're given f of x is equal to 2x minus x squared, and g of x is equal to just x squared. Okay, now just by looking at this, we can see that f is a sad face parabola, okay, because it's got the minus x squared. So this is a sad face parabola, and it's going to look something like that. G of x is a happy face parabola, and it's going to look like that. So just by looking at these little rough sketches we can see that f is going to be the upper function and g is going to be the lower function. Okay, but remember, you can find this out as well just by looking at the absolute value. Okay, but here we can quickly see which is upper and which is lower. Okay, so what we need to do now is find the intercepts, because that will give us the lower bound and the upper bound of the parabola. So, intercepts. So what we want is to find where these functions cross each other. That gives us the bounds for this region. So we're going to say f of x is equal to g of x. So 2x minus x squared is equal to x squared. So we can write this as 0 is equal to, we take the minus x squared across, we're going to get 2x squared. Take the 2x across, we get minus 2x. Okay, so we can factor out to 2x. So we have 2x, x minus 1. We can cancel the 2. So this gives us two solutions. So either x is equal to 0 or x minus 1 is equal to 0. And in that second case, we have x equals 1. Okay, so this gives us our two bounds. So the region goes from x equals 0 to x equals 1. Okay, and if we were to draw a sketch of these functions, then we would see that it looks something like this. So we've got g of x looks something like that, f of x looks something like that, and we've got the intercept there and the intercept there. Okay, and we're interested in this region between them. Okay, so that's a quick sketch of what's going on. So that's G, and that one's F. Okay, so let's find out what the area is. So the area is going to be equal to the integral from 0 to 1, because those are the x-intercepts. Sorry, not the x-intercepts, the function intercepts. So one of the intercepts is at x equals 0, the other intercept is at x equals 1. Okay, then we need the upper function minus the lower function. So that's going to be 2x minus x squared. That's the upper one. Minus the lower one is minus x squared dx. Okay, so this will be the integral from 0 to 1, 2x minus 2x squared dx. We can factor out to 2, and then we can integrate what's left. So the integral of x, that's going to be 1/2 x squared. The integral of x squared, that's going to be 1/3 x cubed from 0 to 1. So this is going to be 2 times 1/2 minus 1/3. That's the same thing as 2 times 3 over 6 minus 2 over 6. So 3 over 6 minus 2 over 6, that gives us 1/6. Then we've got the 2 in front, so that's going to be 2/6. In other words, 1/3. So then this gives us 2 times 1/6. This gives us 1/3. Okay, so this green region over here that's highlighted between the functions has an area of 1/3. Okay, let's take a look at another example. Okay, so let's say we have f of x is equal to x and g of x is equal to root x. Okay, so we can do a quick little sketch of these two functions just to see what's going on. So the square root of x, that's going to look something like this. And x, that's going to look something like that. Okay, so I'm only drawing the positive part of f because g only exists in the positive x domain. So we're only interested in that part. So this intercept here is going to be 0, and this intercept here is going to be 1, because that's the only point where x is equal to root x. One's at 0, the other is at 1. Okay, and this is the area that we are interested in. So we see that the upper function is root x, so that's going to be g, and the lower function is x, that's given by f. Okay, so now g is the upper function, and f is the lower function. Okay, so we know which one's the upper function, we know which one's the lower function, and we know the two intercepts of the functions. So now we can use that to find the area. So the area is equal to the integral from 0 to 1 of the upper function, which is root x, minus the lower function, which is x, dx. Okay, so what does that give us? So that will be the integral from 0 to 1. Root x, that's better to write as x to the 1/2. Okay, and now we can use the power rule. So we add 1 to the exponent to make it 3 over 2. Divide by 3 over 2 is the same thing as multiplying by 2/3. So we have 2/3 x to the 3 over 2 minus integral of x is going to be 1/2 x squared. And this goes from 0 to 1. Okay, so if I substitute 1, I'm going to get 2/3 minus 1/2. If I substitute 0, I'm just going to get 0. Okay, let's find a common denominator of 6. So we're going to get 4 over 6 minus 3 over 6. Okay, so then this will now give us 1 over 6. Okay, we've got the same answer as before, but you see that this is a different shape to what we had before. Okay, so let's just go through this one more time. So you're going to be given two functions, one f, one g. You need to figure out which one is the upper function and which one is the lower function. If you can't do that immediately, like in this case, you would then need to look at the absolute value of x minus root x. And this will give you your two cases, one where one is above the other and vice versa. So that is if you don't know which one is upper and which one is lower. In this case, we can see which one's upper, we can see which one's lower, so we just leave it like that. Then we need to find the intercepts of the function. In this case, we can just do that by inspection because it's easy to spot. One of them was 0, the other one is 1. And that gives us the bounds for the integral. So the lower bound will be 0, the upper bound will be 1. Then we take the upper function and minus the lower function. If you did this the other way around by mistake, then your answer would be negative. Okay, but we don't want negative areas here. Okay, so please make sure you do it the right way around. Okay, then you just compute the integral. We've done plenty of those now. And then you get your final answer as the area. Okay, I think that's enough for today. I don't want to go too long into this. So tomorrow we will be looking at some more difficult examples, more examples that involve this, where you can't tell immediately which one is upper and lower. Okay, so that's a bit more difficult. We'll save that for tomorrow. But now please go ahead and start tutorial 4. So there's plenty of questions there for you to do over the weekend. So I recommend starting now. And there are some easy ones just to for some practice, and there's some more difficult ones as well. Okay, remember for your next test, you won't get such an easy one like this. You will get one where you need the absolute value and where you have to do a bit more working to see which one is upper and which one is lower. Okay, but that's later on. We're starting off easy now. Okay, if you have any questions, please post them on the WhatsApp group or send me an email. Remember, we also have 2 tutors available. Their emails are available on the website, so you can email them, and they are also available on the WhatsApp group, so you can send them a message there. Okay. And if you're watching this today, the day after test 1, your marks should be out by the end of today. And then group 3's marks, hopefully I can have that done by tomorrow. Okay, and good luck with tutorial 4, and please ask questions if you need to.